we're going to start solving some exponential equations. Exponential equations, which just means that what this is going to mean is it's an equation with an x in the exponent. So say x in the exponent. So first of all, I'll give you a rule that if we have that a to the x power equals a to the y power, okay, so that means we have the same base, then x would have to equal y. So this is only going to work if we can get the same base. So for example, if I have 25 to the x plus 1 power equals 125. Okay, so looking at the bases, 25 and 125, they're not the same right now, but we can get both of these to be 5 as a base. Since 25 is 5 squared, this is 5 squared to the x plus 1. 125 is 5 to the third power. So let me kind of clean this up a little bit. So this would be 2, when you do an exponent to an exponent, they're multiplied. So 2 times x plus 1 equals 5 to the third power. So when we get the same base now here, 5, then we can drop the bases and just solve for the exponents. Because whatever we'd have 5 to whatever power this is, it's got to be equal to 5 to the third power. So I'm just left with my exponents. So when I distribute my 2, 2x plus 2 equals 3. And I'll have 2x equals 1 divided by 2, so x equals 1/2. Should be my answer. And if I want to check it, so 25, this is going to be to the 1/2 plus 1, so to the 1.5 power. So if I put that in my calculator, 25 to the 1.5 power, plug that in, check it out, it should say 125. Okay, so this works kind of nicely if we can have the same base. If we don't have the same base, so if we can't get the same base, then this is what we do. So first whatever the equation is, we need to isolate the exponent part or parts. Sometimes we might have two, so as much as we can, we're going to isolate the exponent parts. Then we take the logarithm of both sides. Take a logarithm of both sides. And this could be any base. Underneath the logarithm, any base. So depending on what the base of the exponent is, usually that's going to help us figure out what logarithm to take. And then from there, typically we're going to use our logarithm properties to solve. Use the logarithm properties to solve. Okay, so let's do an example, kind of keeping these steps in mind. So how about 7e to the 2x minus 5 equals 58. Okay, so my first step of isolating the exponential part. This I'm going to have a little bit of work to do. So I'm going to add 5. 7e to the 2x equals 63. Not done yet. Divide by 7. So e to the 2x equals 9. Okay, so I got my exponent part alone. Now I'm going to take the logarithm of both sides, some logarithm. In this case, since my base is e, I'm going to do the natural log of both sides. So let me write that in a different color. So natural log of this side, natural log of that side. So now the logarithm properties that I was referring to, this one I could use the power rule. Bring that 2x out front, multiplied by natural log of e, should equal natural log of 9. Now natural log of e, that's like e to the 1 power, this is log base e. This is going to simplify to 1, or really just kind of be gone. And that's true if we step back a minute. If you have natural log of e, this is just going to drop out and the 2x would come down. So now I'm just left with 2x equals natural log 9. And then I'll go one more step, divide by 2. So if I leave this as natural log 9 over 2, this is considered my exact answer. If I plug that in my calculator and get the approximation, should get somewhere around 1.1. This is my approximate answer. So, I'm going to watch the directions, what their question's asking for.